Okay, we're filling up a cylindrical shaped object. So we're modeling it as a cylinder. So it says if her garden hose flows at a rate of 24 gallons per minute, does she have enough time to fill the pool? Well, fill means what calculation? Volume, yep. What's the equation for volume of a cylinder? That's for a prism, like a rectangular, specifically a rectangular prism. Because think about it, like on a cylinder, we only have height and like a diameter or radius. We don't have a length and a width. So what was it?
Pi r squared times height.
Good. All right. Radius here is 9/2. So just split the diameter in half. And then the height is 3. Oh, wait, I didn't see that the radius is actually not 9/2. Why? There's thickness, right? Now, I don't know why you wouldn't just measure the inside diameter. So this problem, I think, is just, it's more of a math problem to make you have to convert. But in reality, you would just measure right there. Okay, a couple other things about that. A lot of technical and like engineering, that kind of stuff, inside diameter versus outside diameter is a big deal. So think about laying a pipe in the ground. I'm saying this from experience. This is some things that we had to deal with when I was an engineer. Okay, we have dirt up here. The outside diameter determines how far down in the ground you need to bury it, because you don't want, if this goes under a road, you don't want it too shallow because the cars would damage the pipe. So that's outside diameter. But inside diameter, or like looking down the pipe, inside diameter determines how much that it can carry. So the carrying capacity of the pipe or flow amount, right? So, and depending what you're putting in, have you seen like the corrugated, the black corrugated means the side looks like this, right? And it's got ribs on it. Have you seen that kind of pipe ever? That's pretty thin walled, but then there's concrete. It's called RCP, reinforced concrete pipe. It's thick, like thick, some of them. So you definitely need to know the difference between inside and outside diameter.
Is that why it shows the safety sign?
Like I said, in this one, I think it's more of somebody trying to be clever writing a math problem that requires a little more work than it would be reality. Because in reality, before you calculated the volume, you wouldn't measure the outside diameter because it is insignificant for this problem. You would just measure the inside, which would be once you blow it up, or it looks kind of like the blow up kind, you would just take your tape measure across that interior diameter, right? So, because normally, where do you put these kind of things? The pool, I mean, just somewhere in the backyard. Like, who cares how thick it is, right? It doesn't matter. That's what I'm saying. All right, 9 feet minus 10 inches, right? So the diameter, let's say inside diameter is, let me write this word, 9 feet minus 10 inches. Well, that's a unit mismatch, but we could say 9 feet minus 10/12 of a foot, so we convert it to feet.
20 because it's on both sides.
It is 20. Thank you, yeah. (20/12). Now what? Well, one thing you could do is convert to a common denominator if you want to. Like that. Okay. Where did the 108 come from? It's, yeah, so 9 whole things is 108/12 of things. Okay, 88/12. So that's what I'm going to use for the radius. And then a height of 3 feet. That's a pretty deep little kiddie pool, huh? All right, since this is an in context, or what we have called in the past like a in the field or the actual worker calculation, is it okay to use decimals? Yeah, like we want to know the volume of this thing. So we have pi times 88/12 squared. Come on. 88/12 whole thing squared. There we go. Times 3. So 506.8. Okay, in America, our natural, at least it should be, our natural inclination to measure volume is in gallons. Is this gallons? What is it? Well, feet is length. Yeah, so cubic feet, right? Remember we said that a cubic foot is a little bigger than that box on the wall? It would stick out about, I think it was about 3.5 to 4 more inches. So we have 506 of those things. So what do we do to get gallons? Actually, did anybody, I messed up something. Did anybody catch what it was? Why didn't you say anything? You gotta speak up. So say it again. That's diameter. Say it. Yeah, so the radius is half. So this should be 44/12. You can keep saying stuff. Yeah. On these calculators, it's nice to just be able to go grab that and change that top number to a 44. All right, that's better. 126.7. So we're going to be here all day otherwise. Okay. Anyway, what do we do with that? That's not gallons, that's cubic feet. So how do we make it gallons since we're told about the flow rate of our hose in gallons? Yeah. So times 7.48. Times 7.48. We get 900. Let's just round that to 948. It's not going to matter for this one. Now what do I label it? Gallons. Okay. And then how do we deal with the time? "24 gallons per minute flow rate," which I think seems really high, at least for my house. That would never happen. That would be basically, well, have you guys ever used your hose to fill something up at home? That would be almost 5 Homer buckets in 1 minute. There's no way. Like mine barely fills up one, maybe one in a minute. So she has a really good hose. But what do we do with the 24? So look, if you look at your unit analysis, the gallons cancel and the minutes come to the numerator. And we get 39.5. So will she make it? Nope. But at the flow rate of her hose, she would only have to wait another 10 minutes or so. Maybe she could get her swimsuit on while she's doing that, right? Or him. I guess it's a him that's going to be swimming. How'd you do? Raise your hand if you actually got 39.5. One of you. Okay, good. Raise your hand if you got 948. Okay. So where did this problem kind of fall apart? Okay. Yeah, that was a kind of a sneaky little detail that is not in reality something you would have to deal with.
I was just confused why you changed it to 10 inches. Oh yeah, is that because it's done?
No, it's because, well, I guess it could be depending what you're thinking when you say that. So this is the 9 feet, right? And we have that 10 inches on both sides. So to get, if you think about getting inside from both of the sides of the pool, we would go 10 inches in there and 10 inches in there. So there's your 20. Yeah. I know, it's kind of, like I said, that's not really a realistic kind of measurement. All right, let's check your homework. I think I'll just show you answers real quick, and then if you want to do any of them, we can. So 13, although the bottles are the same height, they don't have the same cross-sectional area at every height. So you can read there, the square prism is 16 square inches, and the cylinder is 4 pi, which is 12.56. So Cavalieri's principle doesn't hold there. Okay, 18, I'm going to do 18 because someone asked for that. What was the next one after that? 20, so 20, approximately 1.95 millimeters. And then what was the next one? 22 is 17 bags. Okay. So let's look at 18. Yeah, we can. All right, number 18. Are we good on 13? So I can cover it up, like use that workspace. Is that okay?
Yeah.
Okay. All right, so number 18, Talisa plans a 6-foot deep pond. While digging, she hits a rock 5 feet down. How can Talisa modify the radius to maintain the original volume of the pond? Okay, so the original volume of the cylindrical pond, I'm going to subscript as V sub original. So pi and 3 squared times 6. So let's keep it maybe, well, let's see if this works to keep it in terms of pi. So this is 54 pi. Good so far? Okay. So then the new volume, maybe I'll actually subscript this with the rock, is pi, same situation, only now we're 5 feet down instead of 6. Whoops, not squared. Okay. So let's write it this way. 5 pi r squared. You good on that? Okay. So essentially we want those two to be equal to each other. And we don't know the new radius. So we just set them equal. And it's not going to work. And then just solve for r. That's all. So set equal 54 pi equals 5 pi r squared. Well, the pi's cancel. This is one nice thing about not multiplying by pi. It saves you a step, but also here it's really easy to just get rid of pi. Okay, so now we have 54 equals 5r squared. How do we solve for r with that? Divide by 5 first. And we'll get r squared. This is barely not 11, so like 10.8. Wish I could write a 2. There we go. 10.8. Anyway, how do we get r by itself? .29. Okay. So that's the new radius. It says, how can she modify the radius? So how would you say that is the new radius, but what's the modification? How would you say it? Is that question clear? I think we're good here. She needs to make the new radius 3.29. What are the units there? It's feet. So I don't know if you remember what the answer said on there, but the question is kind of saying, what does she need to do to the original radius? Well, she needs to add 0.29 of a foot, right? Okay. Did that help? Any other questions on that one? All right, and then you said 20 also? Yeah, so if a stack of 40 nickels fits snugly in the coin wrapper, how thick is one nickel? By the way, how much money would that coin wrapper hold? It's not working. I don't know. Can you see if you can fix it? What? No, it turned on. This morning I could not get it to turn on. Weird. Oh, maybe it wasn't charged up. Maybe that's why. Anyway, how much money would be in that coin stacker? 40 nickels. How much money is that? It doesn't matter for the problem, but in life it does, right? How much money is 40 nickels? How much money is one nickel? So it's 40 times 0.05, right? 5 cents is 0.05. It is. Better keep texting Michael B. Jordan. All right. The volume of the wrapper is 27,560 millimeters cubed. All right, the diameter of a nickel. So here's this one. Volume of the nickel is pi times 21.21 over 2 squared times the thickness is what it calls it, which in our formula is the height. Can we agree to call it T for thickness, maybe, just to keep it related to the problem? Okay. And then there are 40 in there times 40 of those. So basically those two are equal once you fit them in there real snugly. So you just set equal. We say, I'm going to move the 40 to the front. And then pi 21 over 2 squared T equals this volume. And then we just solve for T. So in this case, we can just divide. So 27 That was bad. 27,560 divided by 40 pi times 21 divided by, nope. Divided by 2, whole thing squared. Okay, that looks good. And then there's your 1.95. Are you good? You don't look like you understand what I just did. You don't? Here's what I just typed in there. Okay, so in other words, just get t by itself. This is ugly, but it's all just a number, right? We call that a constant. So if this said like 5t, wouldn't you just divide by 5? Okay, so instead of doing that, instead of figuring out what this whole mess is, I just typed it all in at once. Okay, but again, this is the diameter, 21.21, so we have to split it in half. Pi r squared h, but they called it thickness. And then we have 40 nickels. So we're ignoring if there's any space between them, like we're saying that they're perfectly stuck together, right? So if you take 40 of these little nickels, it's the exact same volume as that container for them. Does that help? Okay. Any others on the homework? Cool. All right, let's put prisms and cylinders to rest for a little while. And let's go to the next thing, which is going to be cones and pyramids. Can you define a cone? Can you draw a cone? Something like that? How would you define a cone? Just do your best. Yeah.
Like a circular triangle?
Okay. Circular triangle. That's pretty good. Yeah. So a 3D object with a circular base and the sides meet at a single point. Now, it's like a cylinder that meets at a point instead of staying straight, right? What would the cross section be if we split it vertically? Let me take that line off. So you can leave your drawing. I'm just going to... Okay, so if we took a plane, like think of taking a rectangular knife and slicing down through a Hershey's Kiss. Okay? Does everybody understand what we're doing? Okay, so this plane is going to slice down through like that. What is the shape of the face if I cut that Hershey's Kiss in half and showed you what the face looks like? What shape is it? It's a triangle, right? So even though the bottom is round, all of these what we call cross sections, they're all triangles. They would be different heights, right? What if we didn't have a full size blade? What if we cut it like close to the edge and we just cut it right here? Do you see how like that edge is coming, the front, if we think of this as being round, that front edge is coming up. So this blade would have still just a shorter triangle on it. Maybe it would look something like this, right? Does everybody see what I'm saying? It's hard to draw 3D for sure. But we have triangular cross sections. Okay, that's going to be important. Because if I'm saying triangle, what potentially could we use to solve for something? Thinking lengths.
Trig ratios.
Potentially trig ratios, but maybe just a little less hard. Pythagorean theorem, right? Because think about it. If we have this height coming down here, it's going to be, so now draw this in there. It's going to be perpendicular to the base. So that is the height. It's not the slanted length. It's just the vertical height straight through the middle. You might come across that word slant height. It's not that we're talking about. Okay, with that said, what other measurement do we know about a cone? Like, think of picking up a Hershey's Kiss. You could measure the height, but what else could you measure? Yeah, the diameter, right? Or let's use the radius. Yes, we could do diameter also, but our formula will have the radius. So, in order to quantify things about a cone, we need to know the height and the radius, or diameter. So, let's do the volume. Anybody know it? Okay, well, it starts with 1/3 pi r squared h. What is pi r squared h? Yeah, that's the volume of a cylinder, right? So what is the 1/3 telling us? Yep. So the volume is 1/3 of the volume of a cylinder with the same, this is an important part, let me zoom in on that, with the same height and radius. In other words, it's not just any cylinder, it has to perfectly fit down in there. I should have done this before. I'm going to show you a video. I had one that was bookmarked. Okay, everybody got your formula? Okay.
Get all the perks with a PF Black Card for $1 down and $24.99 a month. Deal ends Friday, December 5th.
Will you turn the light off? Yeah. On your way out. Okay, this is a short, boring video, but it kind of shows you why this is true.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water.
cool because it goes
The volume of the
exactly
cone is
right
a
on.
third of the volume of the cylinder.
Okay. She showed you at the beginning when I was messing with the volume that they have the same height and radius. So if that's not true, then it doesn't work. I have never played through the speaker on that thing. That's crazy. Well, it worked pretty good. Okay, so 1/3 the volume of some cylinder that we have. Any questions on that? Okay. Well, it turns out that the pyramid is the same. It's a third. But what is different about a pyramid than a cone? Is it always? A diamond? That's not really a geometry shape. Okay. All right, let's write pyramid. Okay, so the concept is the same for pyramid. The problem with it is that, kind of like maybe you heard Kinsey saying that we may have a different base. So we can't just give you a single formula specific to everything. So first thing, it depends on the base. But the volume is always going to be 1/3. And then it's just the volume of the prism. If you remember what that was, it was the area of the base times the height. So that looks different based on obviously on the shape of the base. So try drawing some like triangular pyramid. So a triangular base, something like that.
Can you redraw that real quick so I can see?
Yeah, I can.
Can you draw one more?
Okay, so draw some triangle like that. I'm gonna make mine laying a little lower. Too big. Okay, something like that. And then pick a point that you bring each of the apex or vertices to. One apex. Something like that. Mine's not perfect for sure. Okay, you could maybe do it like an isosceles pyramid. Something like that. Okay, anyway, for this, the height is still going to be perpendicular to the base. It's not the slant. Okay, it's the perpendicular to the base. But our base is a triangle, and what do we need to find the area of a triangle? For a triangle? Yeah.
1/2 base times.
Okay, listen to him. Area of a triangle.
1/2 base times height.
Uh-oh. We need an area of this base, which is 1/2 base times height, and we need a height of the pyramid. That's another height. Do you see how that could get confusing? Okay, so keep it clear. Like, are we talking about the height of the triangular base or the height of the whole pyramid? So on your picture, it's going to get kind of busy here. Let's say height of the triangle. And I'm going to continue to add this height of the pyramid. Okay. So what would the formula be for a triangular pyramid, the volume? Well, maybe something like this. 1/3 base times height times big height for the whole overall height. I really want you to understand this more conceptually than remembering 50 formulas. We know it's 1/3 of the volume of the prism. The prism has an area, a volume of base area times height. Okay, let's draw a square or rectangular pyramid. Something like that. Height again is perpendicular. Tell me about finding the volume of a rectangular pyramid. What all do we need to know? Obviously the height, I wrote that, but what else do we need to know? Base area, so what dimensions do we need for that? Yeah, like the length and the width, right? By the way, back on the triangular pyramid picture, over here we need to call this the base of the triangle. Okay, so what would the formula specifically look like for a rectangular, same with the square pyramid? Yeah. 1/3 LWH. Okay, we're just chopping that box into 1/3 of the volume. All right, let's do one more. Obviously, we're not going to draw all of these, but let's do one other version. And how about like a hexagonal pyramid? Why am I drawing so small? Kind of looks like a fire, but oh well. Okay, what would you need to know for that? Well, you're going to have to add our pink line. My pink line is the height, which gets lost in all of this. What else do we need to know besides the height? How do you find the area of a hexagon? Well, look it up. You take notes. Okay, so we need to know the apothem this time, right? And we need to know the side length, the perimeter. So V equals like 1/3 and then times 1/2 AP. So two different fractions in that one. Anyway, that's kind of the idea. So pyramid it's the same concept, but a lot more involved if you have to figure out the area of the base first. Any questions on those? If you were asked to do surface area of any of these, what would you do? Like, let's look at this rectangular prism. Tell me what faces you would have to find the area of to get the total surface area.
Rectangle and the 4 triangles.
Okay, so rectangle and then 4 triangles. That, at least based on the way I drew it, 2 of the triangles would be the same and 2 would not, potentially, right? But for a triangle, I don't know if you can visualize this, but I want you to think of this front triangular face. It would be coming out. Don't do that. It would be coming out at you like this. Like think of this surface, right? So to find the area of that, we would need the height of the side of the triangle. How do you find that? So let me draw that. You don't need to draw this. I just want you to think about it. So think about, we have this front triangle, and we need this slant. Actually, I should put that as solid line. We need this height of the slanted face, not the main pyramid height. Okay? So where are you going to figure out how to do that? Like, where is that going to come from? It's still perpendicular to the front line, right? You see how this could be a little bit harder? Okay. Sometimes it's easier to draw it from the side view. So here's what I'll draw one more picture and then we'll just try this. I want you to focus on that part of the pyramid. Okay, so we're looking at the side triangle. Does everybody see what I'm looking at? Okay, we need this height for the area of that face. Maybe we're told the overall height of the pyramid. Do you see what it's making inside of there? Yeah, it's like if we knew half of the length, if it was centered on the length, if we knew that base, like half of the length, let's say, and we knew the height of the overall pyramid, then we could use the Pythagorean theorem to get that slanted height of the face. Does that make sense? Okay. So it's a little bit of a pain to think through, but obviously you can print and design pictures better than I can draw them, so you can see them a little bit better. But keep that one in mind. See, those are better. I'm going to try that one. Those other ones that I had up there a second ago, those are just like boring applications of the formula. This one requires more thinking. That's why we're doing it. Yeah. Well, do we have time? Yeah, we have time. We're good. I guess now that this is working, I think it must have been dead because this morning I held the power button and like nothing was working.
Right. I was working for the program. No, you draw a star. And you make. I hate drawing.
You hate drawing?
Yes,
How come?
because I'm not good at it.
That's how you get better.
That's how I lose my eraser. No, look at me, it's like gone. Oh my gosh. I'm getting a new eraser. Okay, and then we will do. Thank you. What else did I do when I was
You don't technically need a picture.
for my visualization. So, okay, I don't have one certain. Okay. Thank you. May you be blessed with more erasers. Namaste. Thanks. What do you think?
Olivia, are you gonna do your test today? Or did you finish?
Sometimes.
Yeah, that's right. Because you didn't finish in the BEA till right before. So let's get that done. Can you?
Thank you.
It's just in this bin.
Yes. Okay, thank you. Namaste. Okay, so. If I do Christmas carols, will I get extra credit? What's that one song? It's a Christmas song. Yeah, I like that song. Makes me feel creepy. It's so creepy. Yeah. Makes me feel okay, let me just, okay. Yes. I'm gonna stay tuned.
You guys know what a mole in chemistry is? A mole? Yeah, M-O-L-E.
I'm not in chemistry.
Well, you took it in middle school, didn't you? A little?
No.
What did you learn in middle school?
Literally nothing. Exactly. How to make them use keyboards. Yeah.
So, sketch your little pyramid. I kind of like the dotted version.
Guess that's my bell.
Yeah.
To go.
You didn't have to sketch, that's true. I had yesterday's time in my head. Sorry about that. So I think if you didn't finish this, work on it. I'm not going to give you anything else to do. So